Now, Newton's theory of gravity has been around for over 300 years. So is it still valid, or has it been superseded by some better theory of gravity? Well, at the start of the 20th century, Einstein came up with a new theory of gravity called the theory of general relativity. So straight away the race was on to make some observation or experiment which would distinguish between Newton's theory of gravity and Einstein's theory of gravity. There was already one little piece of observational evidence which pointed towards Einstein's theory being correct and Newton's theory being wrong, and it involved the orbit of Mercury. Mercury moves in a very tight orbit around the Sun. In fact, it's the nearest planet to the Sun, and it also has quite an elliptical orbit, which I'll draw in an exaggerated way here. And what had been noticed over the last few decades is that the point where Mercury gets the furthest from the Sun was actually slowly moving with respect to the rest of the solar system and the background stars. So what you were seeing over a long period of time was that this point on the outside would actually shift around. This is predicted by Einstein's theory of gravity, but it isn't predicted by Newton's theory of gravity. You would have to find some other way to explain this effect. And there was no real reason which fitted with the facts which could explain why this would happen under Newton's framework. We already have some evidence that Einstein's theory is correct and Newton's theory is wrong, but it needed a lot more evidence for people to be really convinced by this radical new theory. So there's another observation that you can make. Einstein's theory predicts that light will be bent by the presence of a very massive objects such as the Sun. So just as the planets curve around in their orbits around the Sun, so light will be very, very slightly deflected by the Sun. So how would that look? Well, if we place the Sun in the middle here, and our position on Earth is up here, and if the light from distant stars passes very close to the Sun, then that light path is going to be bent. And what that actually means is you can see stars which are actually behind the Sun because the light from them is bent around very slightly like this. It's very difficult to observe stars when they're right next to the Sun in the sky because the Sun is so bright that you can't see the stars. So you have to wait for an eclipse of the Sun when the bright light of the Sun is covered by the Moon. So there was a long wait for a lunar eclipse to happen. There was the First World War going on at that time as well, so it was very difficult to make that observation. But when that observation was finally made, it was clear that the light from distant stars was being bent by the Sun. So that observation and many subsequent observations and experiments have confirmed Einstein's theory is correct. Einstein's theory is very complicated. If you want to make predictions which are very, very accurate of the precise orbits of the planets, then you need to use Einstein's theory. So does that mean that Newton's theory is useless? And if so, why do we continue to teach it? Well, we continue to teach it and we continue to use it because it's an extremely good approximation to Einstein's theory. So if you want to make a much simpler calculation where it's not absolute precision isn't important, and you're not exploring these exotic areas of physics where light is being bent by mass, then just relying on Newton's theory is perfectly adequate.